Hello, future engineers, subscribers, viewers, and students. There is another beautiful and challenge problem in plane analytic geometry. This is problem 13 and still counting. This is the problem when the origin is translated at -1, comma 2. Determine the new equation of letter A, the line 3x minus 4y plus 11 equals 0. B, parabola x squared equals 6y plus 10, and C, the circle x squared plus y squared plus 8x plus 4y minus 14 equals 0. So the original problem when the origin is translated at -1 comma 2, determine the new equation of the line 3x minus 4y plus 11 equals 0, parabola x squared plus 6y, x squared equals 6y plus 10, and circle x squared plus y squared plus 8x plus 4y minus 5 equals 0. So for part A, the technique here. So let's sketch the line first by intercept form. So let's assume that each square is 2 units by 2 units. So this is the graph of the line as shown. So the technique is because the new origin is at -1 comma 2, so we change the expression or the we change x by simply -1, x minus quantity -1 minus 0, which is -1, x minus 1. And for y, we change it to 2 minus 0. For, for y, we have um, 2 minus 0, so we change it to y plus 2, because 2 minus 0 is still 0, still 2 rather. So we have 3x minus 4y plus 11 equals 0. This is the original line. So we simply change x by x plus -1 or x minus 1, and y by y plus 2. So minus 4 times y plus 2 plus 11 equals 0. Simplifying, we have 3x minus 4y minus 3 minus 11 plus 11, 0. So 3x minus 4y, uh, 3 first 3x minus 3 minus 4y minus 8 plus 11 equals 0, which simplifies to 3x minus 4y equals 0. So that's it for this first problem. So take note that if this is the new origin, this is satisfied because 3 times 0 minus 4 times 0 equals 0. So the technique is replace x by x plus -1 and y by y plus 2, and we will do that for the rest of these problems. So for the second problem, parabola x squared equals 6y plus 10, so that's the line, and it indeed passes through this point, which is now the new origin. That's why the equation of the line becomes that. So by principle, by our observation here, we simply replace x by x plus -1 and y by y plus 2. So quantity x minus 1 square equals 6 times quantity y plus 2 plus 10. Simplifying and expanding, x squared minus 2x plus 1 equals 6y plus 12 plus 10. Then we have x squared minus 2x minus 6y, then minus 21 equals 0. So that's the new equation of the parabola when the origin is translated at -1 comma 2. So to help analyze, we'll have this another solution to verify that this answer is correct. So originally, the parabola is x squared equals 6y plus 10. And if we transform this to the standard form, we have x squared. So the vertex here is after we transform this to the standard form, because we have x squared equals 6 quantity y plus 11 thirds, y plus 11 thirds, or y plus 5 thirds, sorry. So 6 times quantity y plus 5/3 to make it 6y plus 10. So the vertex would be at 0, comma, negative 5/3. So, right, this is the transformation from this equation to that standard form. The parabola is open upward with latus rectum length of latus rectum 6 and vertex at 0, x minus 0 quantity square, and y plus 5/3 equals 0, so negative 5/3. 0, comma, negative 5/3, it is open upward. This is the vertex, open upward, and vertex at 0, comma, negative 5/3. So with respect to the origin, if this is the vertex 0, comma, negative 5/3, and this is down the new origin, this point will have a new coordinate of 0 minus negative 1, so positive 1. So this is positive 1, and negative 5/3 minus 2 is negative 11/3, right? So the new vertex is at 0 minus negative 1, comma, negative 5/3 minus 2, so that would be 1, comma, negative 11/3, the equation. And if this is the new vertex with respect to that origin, then this equation should be satisfied by that by these points. So that's why one square, or x minus 1 quantity square, equals 6 times quantity y plus 11 over 3 with respect to this new coordinates of the vertex. So the equation of the parabola would be x minus 1, because the new ordinate is 1 quantity square. Latus rectum remains the same, 6, then y minus negative 11 over 3, or y plus 11 over 3. If we expand this is x squared minus 2x plus 1 equals 6y plus 22. And then simplifying further, so we have x squared minus 2x minus 6y minus 21 equals 0. So which is that equation? And this is the alternate solution to verify that the answers are the same. Then finally, for a circle, x squared plus y squared plus 8x plus 4y minus 5 equals 0, the new coordinates of the center would be negative. We have to complete the square. The new coordinates of the center would be, so c sub new negative 4 minus negative 1, because the original coordinates here would be negative 1/2 of 8, that's a shortcut, negative 4, and negative 1/2 of 4, negative 2. So the new center is at negative 4 original with respect to the original origin minus negative 1. So it is then comma negative 2, center of this original circle, negative 1/2 of 4, that's the shortcut, negative 2, then minus 2. So it is at negative 3, comma, negative 4, the new center of the circle with respect to this new origin here. Then let's expand, let's complete the square in both x and y from this equation to transform this circle into its standard form. So we have x squared plus 8x plus 16 plus y squared plus 4y plus 4 equals, transpose negative 5 to the right, then we add 16 and 4 from the left side. We also add same terms in the right side. So to complete the square, remember we add square of 1/2 of the coefficient of the first degree term. So 1/2 of 8 quantity square is 16. 1/2 of 4, 2 quantity square is 4. So that's the technique, if you can recall. So this is x plus 4 quantity square plus quantity y plus 2 quantity square equals 25 or 5 square. So that means the center of the circle originally is at -4, comma -2 as mentioned here, and the radius is 5. So with respect to the new center, which is here, we add, we simply write the equation of the circle with respect to the new origin as quantity x minus -3 or x minus -3, so x plus 3 quantity square plus y minus -4 or y plus 4 quantity square equals radius square, which is 5 square. So which is that original circle. So this is the circle, center -4, comma -2, and it seems it passes through this new origin here at -1, comma 2. So it should be free of constant. The equation should be free of constant. So with respect to the new origin, the center would now be at -3, comma -4. So writing the equation, x minus -3 or x plus 3 quantity square plus y minus -4 or y plus 4 quantity square equals 5 square. Expanding x squared plus 6x plus 9 plus y squared plus 8y plus 16 minus 25 equals 0, and simplifying, so we have x squared plus y squared plus 6x plus 8y equals 0. So as anticipated, that there should be no constant because this new origin would be at 0, 0. So that's why when x and y are both 0, then this is satisfied, which checks that this is correct. That equation is correct. So as an alternate way, based from our technique here, we simply replace x by x plus -1 or x minus 1 and y by y plus 2. So with our technique applied for the first two situations, so we have x minus 1 square plus y plus 2 quantity square, then plus 8 times quantity x minus 1 into the original equation plus 4 times quantity y plus 2 minus 5 equals 0. So simplifying, that's x squared minus 2x plus 1 plus y squared plus 4y plus 4 plus 8x minus 8, then plus 4y plus 8 minus 5 equals 0. So we obtain x squared plus y squared. Then -2x plus 8x is 6x. 4y plus 4y is 8y. Then 1 plus 4, 5 minus 5, 0. Then we have -8 plus 8 equals 0. So in fact, the answer is still the same. So that's it for this video. I hope that you learned something new.